At Navis, we've never been afraid to test our SLAM devices against terrestrial laser scanners. Occasionally, we've been told we're comparing apples and oranges. A fair point. TLSs and SLAM scanners are built for different purposes, but understanding where each one shines and where it doesn't is key to choosing the right tool for the job. And with more SLAM devices on the market than ever before, making fair, meaningful comparisons has never been more important, especially if you want to be sure you're not getting a banana when you were promised an apple. So let's sort through the fruit salad and see what's really going on. We scanned 2 typical environments without using control, an MEP room and an office space. First, we compared data from Navis MLX against a terrestrial laser scanner to establish a baseline. We then tested the 2 next best handheld scanners, one using the same LiDAR sensor as Navis MLX and another with a smaller, cheaper LiDAR sensor. These 2 scanners are often said to produce data that's good enough, but as you'll see, the quality of a point cloud depends on much more than just the sensor. Taking a closer look at the details, the differences become clearer. The Navis MLX scan reveals finer details, such as flanges and valves. The point cloud is cleaner, with a high level of detail and very little noise or spray. Looking at the cross-sections, you can really see the difference in how objects are represented. What's clearly identifiable as a pipe with a specific diameter in the Navis MLX scan is hard to recognize in the scans from the other SLAM devices, making reliable modeling a real challenge. Cuts of the Navis MLX data show clean, sharp edges and corners, the result of more than a decade spent refining our SLAM technology and data processing, so customers don't return from the job site with tilted geometry, double ceilings, and hours of work wasted. The Navis data aligns well with the TLS reference, while the scans from the 2 next best devices show pronounced drift and visible SLAM errors. Since these errors weren't visible in the user interface during capture with the other 2 devices, careful quality control is needed before data delivery to avoid losing trust. These problems become even more pronounced when scanning corridors. Navis MLX provides real-time feedback as you scan, alerting you immediately if SLAM performance drops, so you can adjust on-site instead of finding out later after processing. Other devices, however, show significant drift both horizontally and vertically. Doors shrink, floors curve, and walls bend where they should be perfectly straight, creating a noticeable banana effect. In this example, Navis MLX maintained an accuracy of just 5 mm without using control points. Meanwhile, the same corridor scanned several times with the better of the 2 third-party devices deviated by as much as 20 centimeters. But why does this matter? Because in many SLAM workflows, errors only become visible after processing. Detecting and correcting those issues on site improves data quality, increases reliability, and saves valuable time later. And this is exactly where customers can be misled, being sold bananas as apples or oranges. Because what's the value of a 3D digital representation if it's a misinterpretation of the real world? At the end of the day, it's about using the right tool for the job and trusting the data you collect. At Navis, that commitment to reliability is what drives us. Because knowing whether you're working with an apple, an orange, or a banana makes all the difference. And when quality matters, only the right fruit will do.